Hello, this is Mrs. Wong here. We are doing the run-through for the solutions for your 2E revision for Term 3 WA. This is for set number 1 for Chapter 7 on direct and inverse proportions. So for question 1, you should be able to write down the equation when I say that y is directly proportional to the square root of x. So y equals to k times of square root of x, where k is a constant. And they give you values of x and y, so I'm able to substitute the values in to find the value of the constant k, and that will help me express y in terms of x. For part B, it's a simple substitution. For question 2, you should be also able to form the equation when y is directly proportional to x squared. So y equals to kx squared, where k is a constant. Same thing, they give you values of x and y. So I should be able to find the value of k, and that will give me an expression for y in terms of x. For part B, they want the values of x when y equals to 20, 25. So after I substitute in, I have x squared equals to 225, and I need to take the square root of 225. So reminder, I should have the positive and the negative square root of 225. So I do have two answers for x. They are either positive 15 or negative 15. Now part C, for number 2, is slightly challenging. They want us to find the percentage increase or decrease in the value of the value of y when x is doubled. Now for this, actually we do know whether y will increase or decrease because y and x squared are directly proportional. So when x increases, y should also increase. So the likelihood of it increasing is 100%. But how much does it increase? We will have to now find out. So the equation that we got from part A, y is 9 times of x squared. So when x is doubled, so now my x becomes 2 times of x. The new value of y is now 9 times of 2 times of x squared. Now the square will affect both 2 and x. So that gives us 9 times of 4x squared. What I'm doing the next is I'm rewriting this. So 9 times 4 times x squared is the same as 4 times 9 times x squared. And I know that 9x squared was actually the initial value. So I just do my substitution. So this is from the initially your values of x and y. So the new value of y is actually 4 times of the old value of y. So the percentage increase is now the increase, which is 3y, over the original value times 100%. So the increase is 300%. Let's go on to question 3. M is directly proportional to n cubed. So I write down my equation where k is a constant. And for a particular value of n, m is 46. So I know that 46 equals to k times of n cubed. Now they want us to find the value of m when this value of n is half. So when n is half, now I have half n. So the new value of m is now k times of half n, the whole thing cubed. So this new value of n cubed will give us 1 over 8 n cubed. So again I rewrite, and the reason for me to rewrite this is so that I can substitute the known value of kn cubed. So the new m is actually 1/8 of the initial value of m, which is 5.75. Now for question 2 and 3, you will see that for the last part of question 2 and for question 3, okay, so we see the technique that I have used to compare what happens when the value is doubled, what happens when the value is halved. I use algebra to help me find the new value accordingly, and I compare to the initial value so that I'm able to make comparisons. For question 4, y is inversely proportional to the square root of x. So you should be able to form the equation inversely proportional. So I use the given values to find the value of k. So the equation is y equals to 6 over root x. And I'll use this equation to find the value of y when x is 16 over 49. So that will give me 10.5. Okay, so this will continue from here. For question 5, I form my equation given that y is inversely proportional to the cube root of x. So the cube root of x is here. So I find my equation connecting y and x by finding the value of k. B and C will be simple substitutions for us to find the respective values of y and x. Now for question 6, y is inversely proportional to the square of x. So I write down the equation, and they tell us that x is a positive number. Given that y equals to 12 for a particular value of x, they want us to calculate the decrease in the value of y when x is doubled. Okay, now the decrease in y when x is increased is expected because the two are inversely proportional. Okay, so when x goes up, x squared goes up, but y is inversely proportional to x squared, so the value of y will have to decrease. Okay, so this question 6 is similar to what we have seen in question 2c and question 3 of the same set of worksheet. So what I will do is to write the equation, write down what information the question has given us. So I know that 12 is equals to k over a particular value of x squared. When my x is doubled, so it becomes 2x now, the new value of y will be k over 4x squared. Then it's the same as 1/4 of k over x squared. And the reason why I'm doing this again is because I want to make use of the initial value, okay, that we were given. Substitute that value in. So the new value of y is 1/4 of the previous value of y, which is 3. So the decrease in the value of y is 12 minus 3, which is 9. For question 7, a building can be completed in this amount of days with this amount of workers, and they want us to assume that the workers were at the same rate to find the number of days taken to complete the building with 20 workers. Okay, so I can do a simple comparison. 120 days will require 50 workers. Okay, so we do have to know that the number of days taken and the number of workers are inversely proportional. When I have more time, I can hire less workers. If I need to complete the same work in less time, I will need to compensate that by hiring more workers. Okay, so if I want to find the number of days taken to complete the building with 20 workers, what I can do is I will start off with the information given. Then I divide by 5 on both on this side, multiply by 5 on the left hand side. To see if I have 10 workers, I will need 5 times the time, 600 days. Then if now I have double the number of workers, the time needed will be divided by 2. So my answer for part A would be that 300 days will be needed. For part B, they want to find how many more workers would be required if I want to complete in 100 days. So I'm making use of what I've done for part A. If the number of days is now reduced by 3 times, the number of workers will have to be increased by 3 times. Okay, so I will actually need to hire 60 minus 50, because I'm comparing with the front. So I need 10 more workers if I want to complete the building in 100 days compared to 120 days.